So get stuff, please. Quick review. And if I'm happy to just kind of skip stuff if you don't think you need it. So I don't want to spend time on topics that are unnecessary. Determine whether the given ordered pair is a solution to the system. How would we do that? Plug it in, right? And you have access to Desmos Scientific on the entire test. So you could do this in Desmos Scientific, right? You could just go up and in the top one, I'm just going to include in parentheses, I'm going to replace the X with a 1 and the Y with a -5 and just see when I plug in the stuff on the left side with those values, do I get what's on the right side? I do. The ordered pair is a solution of the first equation, but look, it's not a solution of the second equation. So is it a solution of the system? No, has to work in both, right? Okay. Give me thumbs on that. We good? Okay. Here's an example of, now I changed the wording on the test so it won't even say this, but on the first part of the test, you will not have access to the graphing utility. So you won't be able to, you have to do this algebraically. Do you guys want to see an example of substitution or not? They may want to see an example. I don't want to waste your time. Let's go through a quick one. Okay. So remember, with substitution, we're trying to isolate a variable and substitute into the other equation. Well, here one's already isolated. First thing I do when I isolate the variable is put a box around the substitution equation, and I have to substitute into the other equation. So what used to be an x is now going to get replaced by 4y plus 3. Okay, so what do we get then? This top equation becomes -7 times x, which has been replaced by 4y plus 3, plus 6y. Got to finish this left side. So -7 times my x plus 6y equals -43. Now I've only got y's in my equation, so I can simplify and solve for y. If I distribute the -7, I just get a -28y minus 21 plus 6y equals -43. I could combine like terms. -28y plus 6y is going to give me what? -22y. If I add 21 to both sides, so I can cancel those guys, I end up with, on the other side, -43 plus 21 is -22. So doesn't y just equal 1? And right, if I divide both sides by -22, or just ask yourself, -22 times what is -22? 1. So then we'll just go back to the boxed equation, plug that y value in, and we get x equals 4 times 1 plus 3. So x equals 7. And we'd want to organize our answer as an ordered pair, right? That's how we'd write our answer. So 7, 1. Okay? Thumbs? That all makes sense? Okay, pretty straightforward. You guys have had quite a bit of practice with that stuff, so I think it's going to be no issue. Yeah, we can go through one elimination problem. I picked kind of a harder one. There are easier ones on the test. This is a harder one because I do have to multiply equations. I have to multiply both equations by something, right? What could I do here? I have some options. Really, there's not a huge difference. Probably y's are slightly easier to get rid of. Okay, everybody get that? Give me thumbs on that. Does that all make sense? Top one by 3, bottom one by 5. So I'm getting 15y and -15y. That's my goal. Okay, remember how we show work on this? So distributing a 3 all the way through the top, Miranda, what am I going to get?
12x plus 15y equals
There you go. And on the bottom, multiplying by 5. There you go. 70. That's a big one. Yeah, well, I won't put you on the spot on that one. Okay, and then that's a good thing here because the 15y's cancel, right? So we end up with 12y plus 25y, or x, sorry. 12x plus 25x is 37x. And over here, negative 33 plus 70 is, what do you know? 37. So what's x? 1. And now I'll just plug that back into either one of the equations. Let's just go into the bottom one. How about if I plug 1 into the bottom one, I get 5 times 1 minus 3y equals 14. I could subtract the 5 from both sides and get negative 3y equals 9. So then isn't y just negative 3? Okay, no biggie, right? Okay, give me thumbs. We good on that? If you can do that one, the other ones are easy. Like here would be examples. I won't go through these, but here's examples of some simpler ones. Like that top one, do I even need to multiply? No, I can just add those up right away and the x's cancel. Okay, I can just eliminate a variable immediately. Bottom one is a little bit easier. How come? Say it again. Smaller numbers. Do I have to multiply both equations by something here? Yeah, look on the bottom on this one, I could leave the top equation alone and just multiply the bottom one by negative 3. Everybody see that? So it makes it a little bit easier, right? And we won't, I won't take you through that, but let's at least do that, right? So we know that's how we'd set that one up. Okay? Okay, graph the following. So when we're graphing inequalities, we need to graph the boundary line and then shade a half plane, right? So on that top one, solid or dashed boundary line? Solid. What is the boundary line? Show me with your arms. What's the boundary line look like? Yeah, it's going to be a vertical line, isn't it? Now, and lest you confuse that, remember that if I have x equals a number or y equals a number, those are the weirdo ones, the oddball ones that are horizontal and vertical. How do you know? Well, if our boundary line is the line x equals 1, that's telling me the intercept, right? That's telling me that's the x-axis is getting cut at 1. So it must be a vertical line if it's cutting through the x-axis, right? Give me a 1 to 5 on, everyone's done some of these in Math Excel, knows how to use the graphing tool to graph inequalities. Is that good? You know how to do that? Johnny, Miranda, you good with that? Everybody good over here? Okay. So then this one would just look like that, wouldn't it? Right? Solid boundary line. I'm going to dump the paint on the right side to shade that half plane. How about down here? Show me with your arms what this one looks like. Okay, good. That's going to be horizontal, cutting the y-axis at negative 5. Dashed or solid? Dashed. Good. Okay, so there we go. Okay, and I'm shading below, aren't I? Because y is the vertical variable and it's less than negative 5. On the top one, I guess we never mentioned this, I'm shading to the right because x is the horizontal variable. Greater means further to the right, doesn't it, on the x-axis? Okay, 1 to 5, how are we doing? Okay. Okay, so now let's graph a system. Okay, if we're going to graph a system, what's our process here? Okay, good. We got to isolate y, don't we? Right. So let's take this first one. This will be, how about our blue one? So if this is blue, I got to isolate the y. Let's just do the work right here. How about 3x plus 6y is less than or equal to 6. To isolate the y, what's my first step there, Malin? Got to get the y by itself. So I'm trying to put this in slope-intercept form. There you go. Subtract 3x. Perfect. Good. So those guys cancel. That gives me 6y is less than or equal to negative 3x plus 6. Those are not like terms, so I can't combine them, right? We'll put the x term first. Next step, divide by 6. Excellent. So if I divide everything through by 6, there's going to be my slope, right? Sixes cancel there, and I get y is less than or equal to negative 3/6 simplifies to negative 1/2. X plus 6 over 6 is 1. Okay? Everybody give me thumbs on that first part. How are we doing? Up, down, sideways. How are we? Okay, so then my line, now let's graph this line. Trenton, how would I graph the blue line? Talk me through it. Okay, good. So we're looking for the y-intercept. I'm starting at 1 because that's the value of b, right? Everybody see that? Okay, then what? Down 1 and over 2. My slope is negative 1/2. So I'm going to rise by negative 1, and I'm going to run by 2, and I get another point, and I'm going to connect with solid or dashed? Solid. Shading above or below? Below, and I know it's below because of that. Y is less than the boundary line. Vertically, that means below, right? So there's my shading. For the other line, the red line, this one's a little easier to do, isn't it? Pretty easy to isolate Y for this one. Just subtract the 4x to the other side and I'm done. So those guys cancel. I get y is less than or equal to negative 4x plus 8. Johnny, how am I going to graph that? Okay, so start at 8. There you go, right? Because my slope is negative 4 over 1, isn't it? That's my rise over run. Good, so we're going to rise by negative 4, run by positive 1. Solid or dashed? Good, solid. So there's my boundary line, shading above or below? Below. Okay, so then we want the double shaded region, and this is why we're shading below. Y is less than or equal to the boundary line. And so we can see that the overlapping region is just going to be down here, isn't it? Right? So so the purple defines our solution, and we would have to make sure that we're only highlighting that part in Math Excel, right? Remember, if you need to, you can always delete individual paint cans from regions if you want to get rid of some shading. Okay, everybody, give me 1 to 5. Everybody good on using the paint cans and everything too to shade this stuff? Okay, get a little practice if you're not. Okay, so now we're on to the graphing. Oh, you know what I didn't do on that last one? So here's. Why is that not working? There we go. So here's what this guy looks like then, right? Okay. So use the intersect on a graphing calculator to solve the system. This could not be easier, right? All we're going to do is just literally graph the two equations, find the point of intersection, and that's your answer, right? Okay, does that make sense? They want it. How do they want your answer? You got to read this carefully too. They want them to the second decimal place. Okay, so round the coordinates to the second decimal place. So then what would this give us for our solution? Negative 1.414, right? Sorry, you told me that. I wasn't listening. Comma. It was to round to 2 places, we have to go look 1 place beyond that, right? If it's a 5 or higher, we round up. 4 or lower, we round down. Okay. How about this one? 0.57. Good. Okay, thumbs? Piece of cake, right? No big deal. Okay, how about this? You'll have access to the graphing calculator on this one too, but we got to be able to set it up. An auditorium has 750 balcony seats and 1,900 main level seats. If tickets for the balcony seats will cost 13 less than tickets for the main level seats, what should the prices be for each type of ticket so that the total revenue from a sellout performance, what's that mean? What's a sellout mean? All the seats are sold, will be 88,300. Okay, so our goal here, now what do we do on these things? First of all, the first step is you have to write down what are the variables, right? And how do you know what the variables are? What's being asked? Those are the unknowns. What should the prices be for each type of ticket? So there, my unknowns are the prices for balcony seat tickets and main level seat tickets. So I'm going to call those X and Y. Okay. All right. So now I've got 2 variables. So I need 2 equations. Let's see, Mackenzie, how about the red sentence? Is there a way to turn that into an equation? Balcony seats will cost $13 less than main level seats. Okay, good. Balcony tickets X are, which means equals, 13 less than main level tickets. Good, so that's going to be Y minus 13. Everybody agree? So there's our first equation. Okay, there's the red equation. Give me thumbs on that. I need feedback. I need to know where we are. Okay. Ben, how about the next one? This is maybe a little bit trickier. If the revenue from a sellout performance is 88,300, how could I do that? What's that going to be?
Y equals 700 divided by 88,300 divided by 19,000.
Okay, so now let's look back at this for a second. They're telling us that the auditorium has a total of 750 balcony seats. We're going to sell all of those, right? And it has 1,900 main level seats, and it's a sellout, so we're selling all of those. What's going to be, we want the total revenue to be 88,300. What's going to be the revenue from the balcony seats if each ticket costs X dollars and we're selling 750 of them? Okay, good. So we're going to get the total revenue from a sellout is going to be the money from the balcony seats plus the money from the main level seats is or equals 88,300. Okay, so then does it make sense that the money from the balcony seats is going to be 750X? And I guess I gave away, well, what's going to be the money from the main level seats if there's 1,900 seats, Y dollars a piece, 1,900 Y, and that's going to equal 88,300, right? Everybody see that? Okay, so that's my second equation right there. Now I've got 2 equations, 2 unknowns. You guys can do this with Desmos, right? I'll give you technology on all the word problems. So you could just graph those 2 equations, and let's see, what's that look like if we do that? Looks like that, right? And I'm going to have to probably zoom out a little bit to see that, but there it is. My intersection is at 2437. So what's that telling us? $24 for a balcony seat, $37 for a main level seat. Okay, it's telling me the values of X and Y, right? Is that what you said? Well, we know that they're telling us balcony seats will cost $13 less because you're further away, I guess. Okay. All right, so if we filled in the blanks here then, so balcony seats will be priced at $24 and main level seats will be priced at $37. Okay, give me thumbs. Again, you got technology for the solving part of that, right? Okay. How about one like this? A landscaper plans to dig a rectangular garden whose length is to be 2 feet more than the width. If the landscaper has 36 feet of fencing to enclose the garden, what should the dimensions be? Well, there's the question, right? What should the dimensions be? That's just asking for X and Y, right? The length and the width, okay? So how about the red statement then? Length is 2 feet more than width. Yeah, everybody get that? Right? So is means equals, so length, Y, is equals 2 feet more than width, X plus 2. Boom. Give me thumbs. Okay? Bottom one. If the landscaper has 36 feet of fencing to enclose the garden, what do we call that? If 36 feet encloses the rectangle, what's that quantity called? Perimeter. There you go. Right? So the perimeter, which is 2x plus 2y, is equal to 36. So there's our two equations. We graph them in Desmos. I find the intersection, and what's it telling us? Well, telling us that the ordered pair is 8, 10, and we said that 8 was the width, right? So the 8 goes there. The width was 10. That's the length. Yes. Because that's the, okay, where do I get that? That's the perimeter. If I look at a rectangle, right, we're saying that's X. Actually, let's do it the other way. We'll call that X. So that's X, that's Y, and that's Y. So the distance around is going to be 2 X's plus 2 Y's. Okay, make sense? Okay. Is the ordered pair 4/7 comma 0 a solution of the inequality? How could you tell? Graph it or plug it in, right? Just plug it in and see what you get. If I plug that in, the answer is yes. How come though? Because if I plug in 4/7 for X and 0 for Y, well then 5X plus Y turns into 2.85 blah, 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 which is greater than 2, okay? So I get a number greater than 2 on the left, so it makes sense, okay? Give me thumbs. Good? All right, we're getting there. How about one like this? Okay, this is a little bit tricky because we're working backwards. This time they're giving you the inequality and or the graph, and you've got to write the inequality, right? Okay, so first of all, what about, we want this to be in slope-intercept form, right? So what's the value, based on the graph, I pointed it out, what's the value of B? 3, okay, so we know one thing right away is, oops, I guess I want to do this. I'm taking that away first. There we go. Okay, now I'm back on track. Okay, so what about the slope? Well, if we made a slope triangle here, like if we pick, here's 2 points that are already defined for you, right? So if we make a slope triangle out of this, look, I'm rising by -3 and running by 3. -3 over 3 is what? -1. Okay, so we know the slope is -1. Okay, there's my slope triangle that shows us that. Okay. Now we need to know what kind of inequality are we using, solid or dashed? Solid, and are we shading above or below? Below, so which one would I use then? Less than or equal to. Okay, and there we have it. Okay, give me thumbs, we good on that? Okay, last one. Graph the solution of this system. Okay, the only thing that's tough about this is just that you've got 3 inequalities there, right? But at this point, for this one, I believe I gave you, I can't remember if I gave you the graphing on this one or not. I think I did. I think I gave you access to the graphing calculator, but you don't even really need it, do you? Because if I graph all those things, I can see whether I graph it using Desmos or not, I can see that I end up getting this triple shaded region down here, right? That's the solution then. And so if I want to show this solution in Math Excel, let me just see something if I'm missing something. No, I guess I'm not. Nothing up there. Nope, I guess not. So what would I need then? Well, they're all solid boundary lines. Where would the paint can go when I graph all these boundary lines? It's got to go down there, doesn't it? Right? It's where all three of them overlap. Give me 1 to 5 on that one. How are we doing? Is that good, or do we want to go through one of those like in Math Excel? Okay. All right, I'm gonna let you work then. You guys are charging through this stuff. You're doing so awesome. I don't want to waste your time. I'm gonna let you work. You got finish up the review if you haven't done that. If I don't, do I have practice tests up for you guys on this one? Okay, would you like me to put up practice tests? How many people would like to have access to a practice test to go through tonight? Okay, I'll put them up.